So see the diagram here. See, this is the first diagram. What you see, the system without feedback. So you have an amplifier of gain A1. It has an input signal Vs. The output signal is V0, and I am adding a noise. You have a noise of voltage Vn. See, generally, you cannot actually represent noise by an voltage source. Just to mathematically quantify noise, I am representing noise by an voltage source Vn, and it is random, so I cannot say what polarity. It can be positive, it can be negative, it can be zero, so I don't put the polarity for noise. So the first case, the diagram what you see here, it is a normal amplifier without feedback having a noise source. Second diagram what you see, the same A1 and Vn are there. I'm going to introduce a negative feedback, and I'm going to add one more amplifier before Vn. I'm going to call it as A2. Okay, so the difference between first diagram and second diagram is very simple. First diagram is without feedback, second diagram is with feedback. So I'm going to prove that the second diagram is going to perform better when compared to the first diagram. Okay, so see here. So I'm going to consider an amplifier with input signal Vs, the noise signal is Vn, and the gain is going to be An. So you know the signal to noise ratio of the thing is given by, so SNR is going to be Vs by Vn. What is the input signal to the amplifier, and what is the input noise to the amplifier? So I can write SNR equal to Vs by Vn. See, you have several SNR, you have input SNR, you have output SNR. So a lot of things are there. Here I am going to consider input SNR. So the first diagram you see, the input signal to the amplifier is Vs, the input noise to the amplifier is Vn. So the input SNR is Vs by Vn. So ideally, when Vs is 0, SNR will become infinity. But Vn will never be 0. It will be very, very small. So SNR value will be very, very high. Okay, that is the first case. SNR value is Vs by Vn. The second diagram, what I am doing, I am adding another amplifier with gain A2, which is not suffering from noise. Because before A2, you see, there is no noise source. So A2 is free from noise, but A1 has this V1 getting amplified because of A1. So I am adding one more amplifier A2 which is free from noise because there is no noise source before the A2. You have only the noise source before A1. So I can say A2 is free from noise, but A1 is having noise connected to the input of that amplifier. So I'm going to apply negative feedback throughout this amplifier combination A1, A2, so that I am going to see what is the effect of the negative feedback. So by applying the negative feedback through the overall cascaded block, I am going to see what is the overall gain. So I can calculate the output voltage by superposition theorem. So you have two voltage sources, and I want to measure V out. So I cannot find that when both the sources are simultaneously active. So you have studied about superposition theorem. It states that when you have multiple sources in a circuit, the output is going to be addition of output of each source. So when I have Vs and Vn, first I will remove Vn. I will find the output only because of Vs. Then I will have only Vn. I will remove Vs and I find the output only because of Vn. So V0 is going to be the output, addition of output of both the cases, output because of Vs plus output because of Vn. Okay, I'm going to use superposition theorem. Okay, so assume in the first case this Vs is not there. So Vn, the noise source, is not there. So it is short circuited. So removing the voltage source means you are short circuiting it. So I have an amplifier A1, A2, between them no Vn is not there. I'm going to remove this Vn. Okay, so I'm going to have only the input Vs, and when I told you when two amplifiers are in cascade, the overall gain is product. So I can replace these two amplifiers by a single block, and the gain is given by A1, A2. When amplifiers are in cascade, I can replace them by a single block, and gain is going to be product of their individual gain. So I can replace these two amplifiers by a single amplifier of gain A1, A2, and you have feedback beta. So what is the effective gain with feedback? When the formula AF equal to A by 1 plus A beta. Okay, AF voltage gain with feedback AF equal to A by 1 plus A beta. Here the A is going to be A1 into A2. I have two amplifiers in cascade. So A is going to be A1 by A2, A1 A2. So AF will be equal to A1 A2 by 1 plus A1 A2 into beta. Gain is output by input, so output V0 by Vs equal to A1 A2 by 1 plus A1 A2 into beta. So V0 will be equal to cross multiply A1 A2 into Vs by 1 plus A1 A2 into beta. This is your first expression. Is it clear? So they have not specifically written the expression separately in the textbook, but first expression corresponds to the case where there is no noise source, no Vn, and second expression corresponds to the case where there is no Vs. Okay, it corresponds to the case where there is no Vs. So in first case, when there is no noise source, no Vn, A1 and A2 are in cascade. So the overall gain is A1 into A2. So the overall gain is A1 A2 by 1 plus A1 A2 into beta with feedback. Multiply